The Ultimate Remote, or perhaps more accurately, the journey to the Ultimate Remote. This was essentially a prototype I built. And you might think, well, that looks like it used to be a remote. And it was. It was a remote at one point. But I wanted to make a fun gizmo. This has a laser pointer in it, and it's a flashlight. I built two, one for me, one for my wife, and she thought it really cool. She liked hers. Hers had a purple laser. Purple is her favorite color, and she had it for quite a while. But the first time she really got to use it, somebody stole it, and she lost it. She was just devastated. Now, these buttons down here were just dummy buttons I left in there for fun. It still runs on the same batteries, 2 AAA batteries. So it's basically was for fun, like I play laser games or something. I have a phaser or a blaster or whatever it is. It's more what it was goofing around with. So she lost hers, and I told her, she was really devastated with it, the fact that she lost it, and I told her not to worry about it. This was more or less a test prototype. While it's kind of cool and fun, I wanted more. I knew I could get more out of it, but I was racking my brain around a couple things trying to figure out how. So here's the problems with this. First, it's not rechargeable. Second, it's very limited. It only does 2 things. How many times do you need to do a laser pointer or a flashlight? I'd like more usability in it. And the cheap lasers, which I got the lasers out of laser pointing pens that you can get, laser pens, whatever you want to call them. Cheap lasers, which are what are in those, are notorious for leaking IR radiation, which is not good for the eyes. Now, I don't know how long of an exposure or anything would be needed. My plan was to get lenses, which I did get lenses in this one, to block that light. But I told my wife, so just use the laser pointer sparingly, so whoever stole it might lose their eyesight. Don't know. I'm not wishing anything bad on anyone. But just a fun little gizmo. Beep boo. Another big drawback for it is because the button is so prominent, and if you look in the profile, if you put this in a bag, briefcase, pocket even, it's going to just be forced to drain the batteries pressing on it. So it's not good in that regard. I would say it has several design flaws. And if you're wondering where I got the remotes, when you work as a field tech for a telecommunications company, depending on the month, they tell you to throw out the old remotes. I say depending on the month because one month they're saying like, oh no, we need those back so we can refurbish them, and next month, no, we don't want them back, just throw them out. It's like, oh, whatever. So that was this one. So what is the replacement? Tra-la. And I know some of you are thinking, what on earth is that? Yes, it looks janky. I'm sure somebody will say, hey, you could have 3D printed or this and that. Yes, I could have, but first, I don't have a 3D printer. Second, I don't want a 3D printer. I'm really not interested in getting into that. And there are things, I prefer the old school ways of, working with things in your hand. The thing is, what I did with the old one, to cover the buttons I didn't want because I didn't want holes there, I put masking tape over it. Obviously, it was taken apart. On the inside, I put JB Weld. This is an epoxy glue. It's a plastic. I've seen it repair everything from metal components, equipment, lead cell batteries, actually. Somehow a hole got in the side of it. I wasn't involved in that. But yeah, I have seen these repair that. JB Weld is really cool. So what you do is you mix it up, put it on the inside, put the tape over it, flip it over, put it in there with a toothpick. You work around, make sure there's no air bubbles in there, and you can get a pretty nice finish. It has a little bit of texturing that's from the tape. That's basically what I did here. But I took up a little notch here, and then I started sanding and buffing this up. You can get a smooth, perfect finish, but I found, as it may look janky, the feel is actually pretty cool. It actually gives nice texturing and nice feel to it. Before I go into the nuts and bolts of all this, I'll go over what all this is. First, you have this switch. Flip it over. This light tells you the laser is armed. Flip the switch over the other side, it powers the other devices, such as a cell phone charger. It's blinking because it's low batteries right now. My wife doesn't charge it or do anything with it. You have a flashlight, which is not going to turn on because it doesn't have enough juice in it. And so it has a flashlight, can recharge anything through USB, has a laser pointer in it that is protected, so the eyes are fine, but it has a red laser in it. I'll cover that again later. Light, actually 2 different flashlights I took apart to get it. It's not like a big concentrated beam of light going out, but it does have decent light. And in the old battery compartment, you can put your charging cables. You have space in here. This is how you charge it. It has a little circuit board on there. I have a bolt through here holding it together. The reason for that, one remote I found, this as big as remote as this was, I found it was not enough room for what I needed inside. So what I did is had another remote basically cut in half, maybe the top third of it. I used that, stacked it in here, used JB Weld to glue that in place. My hope was to get this to snap together. It deformed slightly so it wouldn't snap together, but that kind of worked a little bit better because it gave me a little bit more room. Holding it together held a little nice rigid, so it gave me a little more room to work inside. Putting the bolt through here to hold it also gives a little more of a industrial look. So yeah, that's how that works. I have another piece of plastic I glued on here because it'll give me a flatter surface to work with mounting some of the things. I'm not going to open it to show all the inner guts because it's tight. But now, a quick tour of just how I built this. Me being me, I like complexity. You know, this the thrill because I can. Add this all complexity in there, so that's why I wanted to do this upgrade to it. But I was mixing many different voltages and demands. The first big hurdle, if you watched my video on power supplies, building your own power supply, that prototype I mentioned in there was for this. I've been working on this literally, it was over a year process trying to get this thing to work. The batteries originally, actually, if you're curious how I don't store all my stuff like this, but different components and stuff, what I do, I'll drag this whole thing in here, get a feel for it. I'll have something that either breaks or something of interest. I'll have the bits here. I'll take it apart and think maybe there's something in here I can use or rob, or maybe I plan to fix this one later. This one broke, I see what was wrong with it, and I might fix it. I might not. We'll see. Sometimes I'll put papers in there noting what the voltages were of the components. I have one of those handy. Here's one. Why did I put the tweezers in there with it? I don't know. Anyway, but it will say on here, signal blink, 4.5 volts, so I know later on what it ran on if I want to use this for something else. This way I'm not racking my brain trying to figure, oh shoot, what was the voltage of this? Or risk damaging it, because if it's designed to run on 3 volts and you connect it to like 4.5 volts, just making up numbers, it might work fine, but you're overpowering it. That can cause it to either shorten its lifespan, dramatically die, as I had some LEDs do on me a long time ago. Anyway, so getting back to the main point. I want to show you the batteries, which are pretty easy to get hold of for cell phones, are not going to fit in there. I've seen some that were narrower and longer, but they still wouldn't fit or wouldn't fit within the space I had. Couldn't have them going up too far. There's all sorts of problems with them. If you want more information on the batteries and the battery bank, you can watch that video. It's called Build Your Own Battery Bank. So I had some problems with that. The problem was the circuits I can get to charge a lithium-ion battery, which are the ones you generally get hold of for stuff the size, cell phones, for example, run on 4.5 volts. At 4.5 volts, if you use different batteries that have different voltage, they may not charge off of that circuitry. For example, I don't want to dig everything out. Like this charging circuit for this battery bank runs on the 4.5. I couldn't take this on a battery. The batteries I actually got for this are cadmium ion hybrid batteries, I think they were. They're basically like AA batteries, and the size of AA batteries, but just squished a little bit so they're a little flatter. Those, however, each one was 1.2 volts. I have 6 of them in here, and the center of gravity, it sits really nice in your hand because it balances right about there. It's really nice. So it's not like one of those things where you have all the weight up here or all the weight in the back. It has a nice feel. But the problem I run into is trying to charge it, because I couldn't use the lithium-ion batteries. The batteries that could fit in here were cadmium hybrid. And I wired them together. What I ended up doing, 3 in series and 2 series in parallel. What that means is there's 3 batteries wired positive to negative, and a second group of those that are parallel. That gave me a large amount of volume of power to use. And within the voltage range, it wasn't overly excessive or wasteful. It came out very efficiently for what I needed. Now, I'll explain what all of that means. Not as super in-depth, but I'll explain it. But I couldn't charge them off a lithium-ion battery. What I had to do, I hunted around just charging circuits and found these guys. A lot of times when you buy these types of circuits, they're together in a block, and you can just snap them apart. They have marked on here positive and negative. Just solder on there what you want, or you can use the port that's plugged in here. These are micro USB, I believe. So you have the charging circuit. This would charge this, and that's basically what is wrapped up at the bottom here. So I was able to finally charge them. Yay! Okay, now we can charge them. That was an accomplishment, all the work I had to do to figure out how to get them to wire together, because I also needed different voltages from inside to get this all to work. So now that I got that going, the light to tell you that the laser is on, which the main reason I did that was so that you could indeed know that the laser is on and you're wasting power by doing that. But I wanted some complexity for fun. That light, I think it took 1.3 volts. It was around 1.5, which obviously is a lot more than what the voltage are putting out, because in the series they are putting out 3.6, if memory serves me correctly. If you wire, again, overpower it, it will shorten the lifespan, fry it. Don't want to do that. So how do I handle this? So I have a resistor on, when you flip the switch over there, I actually have a resistor dropping the voltage down to what that would take. Then on another wire coming off that, I go through the switch here to the laser, which the laser is mounted on the side over here. Technically it's a diode, but we'll call them lasers. So that puts that out over there. That's how that circuit works. Then flip the switch the other way, it's connecting the power to the other switch. If you flip the switch to the right, it's powering the charging circuit here. Now this, if you watch my build your own solar charger. Same circuit. What that is that circuit, as long as it gets a minimum of 5 volts, it can take up to 20 and it will charge it. I did some testing with it and it didn't charge any faster if I put 20 volts in it or if I charged it at 5. With that information, what we can do is dropping it down to make the batteries last longer. If you put up that 20 volts from here, it's going to drain the battery quicker. Now you might be thinking, wait a minute, you just said it generates 3.6 volts. How are you getting 20 volts? I call them amplifier circuits. They're technically a step up. Amplifier, if you start web searching amplifier circuits, there's a lot of circuits I came across that are all AC. It took me a long time to figure out what verbiage I was looking for to get me to do the same thing in DC. I know it's out there. What's this thing called? Finally stumbled upon it. It's called a step up. Don't ask me why they changed the name. Circuit for that, actually, want to see what that little guy looks like. These guys, similar, and these little prefabricated circuit boards are pretty easy to get. They're really available. And you can do a lot of things with them, up to and including, you know, pretty much whatever you want. But you solder the leads on, positive, negative, in, out. Actually, in is over here, out is over here. Again, you have a micro USB port. Basically, this is a variable resistor. You can turn it up and down, dial it into the voltage you want. You're trading amps for volts, and you're shortening the life. Not the lifespan, how long it will work, but you're draining off more charge than it would have. But yes, you could literally take one of these, connect it to a AAA battery, have it power one of these charging circuits, and you'd have a phone charger. You know, you could do that. It would be inefficient, and unless you had like a bunch of old batteries, you just wanted to use them up for something, but you need a battery bank or something, you could do that. But you want to check it with a meter, because if you dial that knob off a little bit, you could be sending a lot of voltage and fry it through. So that's how the amplifier circuit portion worked. Then switch over, we have the flashlight. Flashlight ran, I think it was on 3 volts, and it's getting 3.6. So I have just a little resistor there just to knock the voltage down a little, just to make sure I don't hurt my poor little LEDs. The laser pointer itself, it's really difficult to take the laser pens apart. The ones you'll see them around advertised, there's a purple, green, and red laser. If you take them apart, ironically, the inner workings are quite different. The red laser, really robust, really easy to take apart. Green laser can be problematic. The first time I did taking apart the purple laser, it worked fine. Every other time I have tried, the purple laser has died trying to take it apart. So I kind of gave up on giving her that purple laser. But what I did find in my work was throwing out some old scrap. With it were some diodes, or as we call them, lasers. And they're red, but they're actually much higher quality and nicer overall than the ones I can get at the General Electronics. Nice solid beam, nice voltage. And my manager has to ask him a couple times about getting me the product spec sheets. I knew how much voltage to put into them because I didn't want to fry them. But yeah, they took just great. So yeah, it was fun. And that is basically how I built this. It was a fun project. It's not hard to do. I mean, literally, you could just figure out, okay, I want to do this. I have a battery bank. I could tie into the power to do this. What could I do with that? And just start building your complexity on it. It's not hard to do. It's kind of fun. And let me tell you something. people that have fun with these app development and things like that. When you actually hold something in your hand, I built this. It has a fun element to it. This right here, that I can show people, see what I did. I didn't just beat level 87 on this game. No, I actually built this right here. It's a fun element, physical, it's there. One of the things that actually got me to try to get this project going sooner, because it was on the back burner for, it sat there for, like I was working on this about probably a total, at least over a year, maybe a year and a half. For a while, I just gave up on it, just to let it sit there because I didn't give up, but I just wasn't actively working on it because I was having such a hard time tracking down some of the circuitry and figuring out how I was going to wire this and fit it all in there. But my wife had a job where her cell phone was always going dead on her. And I thought, oh, she needs this. So it gave me the initiative to, hurry up and get this thing together. I got it together, and she doesn't work there anymore. She doesn't. And so it's for a need that isn't there anymore. But she has it. If it ever is needed again, it's there. So there it is, the ultimate remote that doesn't actually control anything.